Hello, everyone, and welcome back to NetApp ONAIR. As always, I am your host, Nick Howell. Thank you so much for joining us today. We have got a good one lined up for you. First, we're going to do some quick housekeeping, though. You want to make sure that you get into our Discord community. That is the place to be. To quickly find it, you can go over to netappdiscord.com, or if you know Discord, you can just go to discord.gg/netapp. If you've already got an account, it'll send you right in. Go through our onboarding, get into the community. There's over 5,000 people in there now. It's amazing. A mix of executives, some of our subject matter experts, such as some of our guests here on the show. Our support staff hang out in there, and many of our partners and your peers all hang out in there, helping each other solve problems every day. So come join us in Discord. That is the place to be for all things community here at NetApp. We're wrapping up the year this year, and really quickly, I wanted to recap a couple of things. Insight was really instrumental in how I want to take the show forward. There were a lot of people that came up to me and said, Nick, we have no idea. We're new customers. We're new to NetApp. We're new to ONTAP. We don't know what all of these flex and snap words are. And I said, say less, I got you. So we've done episodes on SnapMirror and Vault policies. We've gone over Snap Center to take care of any of your backups. We've given you updates on the latest and greatest from ONTAP with Keith Asen during our launch week a few weeks ago. And today I wanted to get a little bit more advanced and get into the application side of the house as we get into how do we protect applications and provide continuous availability of mission critical applications, because that's a part of it too. We can talk backups till we're blue in the face. We can talk replication till we're blue in the face. But it's really about those mission critical applications and keeping your business online, that where the rubber really meets the road. So it's all important. It's all part of this bigger picture that we have. And I really wanted to get into that to close out the year. So this is going to be one of our final episodes for this calendar year. We're going to be talking about SnapMirror Active Sync, the artist formerly known as SnapMirror Business Continuity, which we'll get into some of that. And then finally next week, to really close it out, we're going to be giving an intro and a deep dive into FlexCache, which is an interesting one because I haven't really spent a lot of time myself with FlexCache. So we're going to have our resident TME for FlexCache, Mr. Elliot Ecton, on next week to go over that. But today we're going to talk SnapMirror Active Sync. And to do that, I need to bring in maybe one of the OGest of OG people at NetApp right now. I don't know if he's got the longest running tenure here right now, but let's get him up here and ask him. Mr. Jeff Steiner. Jeff, how you doing, man?
Hey, doing all right. I know I'm not the longest tenure at NetApp, but if you're talking about experience with NetApp, maybe. So I installed my first system in 1995. I had an F30 and a 220. I forget if it was called the nuclear banana or the atomic banana. And actually, I went looking up online to look at the specs of this a while back. I believe it was the 220 maxed out at 16 gigabytes of storage. And I had to look at that like multiple times, like you can do something with 16 gigabytes. And yeah, that really was the spec. Had an external power supply and everything, this giant shoebox sized brick that you had to find a place for in the rack. And I've just been working with it ever since, through a number of different employers. And then finally, frankly, what I noticed is that my NetApp account team had been the same guys for years. And I figured, I bet that's a pretty decent place to work. And about 18 and a half years later, I'm still here.
We had somebody post a picture of an old toaster this morning, and it had the old network appliance logo on it. And they were asking, it was from a partner. And they asked, like, when was this from? We just unearthed this thing in our warehouse, and it was an F825. And I had to go look it up. It was one of the ones with like the brushed aluminum bezels, if you remember those. And I looked it up, and they were discontinued in 2002, which means they would have probably come out in 98, 99, something like that. If we take typical 5-year cycles and stuff like that.
I don't know if it's still out there, but there was a financials company that was providing updates every so often where they had like an F720 that was kind of forgotten during a migration. It was still there. And last I'd heard, it had something like 12 years of uptime, and nobody was using it anymore. And I'm sure the drives were slowly failing, but they just wanted to see how long can they go before it died.
People don't know Like my favorite example is probably the Cisco 6509 chassis switch. People don't know how much old infrastructure is still out there running the
Yeah.
world. Like the backbone of the internet is still really propped up in certain pops by 20-year-old tech that's still running strong.
And it bites me sometimes because I get pulled into these escalations where somebody's database is running too slow. And I'm looking at all of the common things and thinking TCP congestion algorithms, windowing. I mean, maybe there is a bug or something like that. And then what it turns out to be is they have one of those ancient switches where there would be like 4 10 gigabit ports, but then they all share a single 10 gigabit channel to the backplane. This used to be a really common thing. Like you go into a data center, and in the early days of 1 gigabit Ethernet, you'd see this all the time. You go into the data center and regular servers are just plugged in all the ports. But then you've got the one switch that in many cases was used for the ONTAP system, where port 1 is used and port 5 and so on. So it's port, empty, 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 port, empty, 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 because those 4 gigabit ports all shared the single 1 gigabit uplink to the backplane.
Wow.
And we're still occasionally running into switches that are that old.
That's crazy to me.
And you just don't think of that as causing a problem.
Right. So Jeff, as you might have heard in the opening, we've been working on this series really since Insight to not only update people on the latest and greatest of the goings-on with all of the Flex and Snap words and everything to do with ONTAP and our systems and things like that. That's obviously a big part of the show. But I got a lot of feedback at Insight this year from people that were new customers and had never administered ONTAP on a NetApp system before, and were just looking for some information. And it surprised me to find that, yeah, they're right. There's not a lot of that kind of stuff out there. So we're working on fixing that. Give us an introduction, if you can, to SnapMirror, the Active Sync portions of it, or if there's anything SnapMirror based that begets Active Sync that you want to lean into as well. But like, pretend I've just bought my first NetApp system, and why should I care about SnapMirror Active Sync?
All right. So I'll start a little bit earlier in the story if you're a completely new NetApp customer.
Yeah.
What it really all comes down to is snapshots. And personally, I think our account teams need to talk up these fundamentals better. Like if you go back 15 years, we were the snapshot and clone people, and we were the only game in town. So if you just wanted a bunch of LUNs to just sit there and serve data, there were a lot of different vendors that could meet that requirement.
Sure.
But if you wanted to do something interesting, then we were it. Like we could clone a database 50 times, and or even if you just wanted one clone, we could refresh that clone almost instantly. And there just wasn't another option. And what's happened since then is it's sort of turned into table stakes, because almost everybody can do some form of snapshot and basic replication and basic cloning. And I think it's easy to think that it's all alike, and it really isn't. Yeah, you can do a snapshot on competing technology, but our ecosystem is so much better. And the reason is because we started with the snapshot and we did it right, and the system was built for snapshots. And then we've extended it where SnapMirror, our basic replication technology, is built on top of snapshots. It's all about comparing two snapshots, moving the changes. Compare two snapshots, move the changes. That's why we're so efficient at doing replication. You're just always moving changes around. If you take two snapshots, each one of them builds on the other. So you're only dealing with changes, not tons of full-size copies. And then you'll find these snapshot technologies everywhere. FlexClones are based on top of snapshots. MetroCluster has snapshot activities in the background. So the story goes on and on. I think that's a great idea, that you get more people showing just how much you can do. Like we've got one particular marquee customer that has over 110 clones of the same database. Every developer can refresh their own personal sandbox every single day, and they do, and they're literally getting 100-to-1 efficiency. It's not just about can you do a snapshot, it's what can you do with all of this.
And that technology is called FlexClone. We're going to get into some of those basics and fundamentals as well here on the show in the future. I told Chris Gebhardt the other day we need to get back to ABC diagrams with the just going over snapshots, because it all really centers around that, as you were saying. Like if you don't understand the basic snapshot, everything else on tap revolves around that. Every auxiliary functionality, every flex and snap word revolves around how we do those snapshots in some way, shape, or form.
And
so I always look at that as the baseline.
A FlexClone basically is a snapshot. Now we changed the name, but I came to NetApp from Oracle, and Oracle is actually responsible for FlexClone. I mean, they didn't write it or anything like that, but snapshots were so embedded in everything we did when I was there. And what happened was the old Oracle applications team would use a directory called an AppleTop, where it's just thousands and thousands of files. And the developers were fully aware that you could take a snapshot of thousands of files instantly. You could keep hundreds of them online. It was great for recovery. It was great for backups. But they were read-only. And they said, hey, we'd really like to be able to have read-write snapshots. Can you do read-write snapshots? And we said, well, no, we can't do that right now, but sure, we could figure out a way to do that. So that's all it is. It's a snapshot that we have just allowed to be read-write. Yeah. And what they were doing with it is just like the first example I gave. They were cloning all of their development environments. So you don't have to sit there for an hour as these thousands and thousands of files got copied to a new destination so the developers continue their work. So
yeah, we would use that's a good example. As a healthcare customer, we would use them. We were on Oracle 10G, I think, at the time. And we were coming from the old world of RMAN and DataGuard. And the very first thing we did was set up Snap Manager for Oracle, SMO, whatever you want to call it. And we took an 8-hour DataGuard window, RMAN window, and took it down to about 58 seconds.
Yep.
With Snap Manager for Oracle. Now, what we did with that 7 hours and 59 minutes that we got back was we started refreshing using FlexClones as a part of the post-script process once the snap ran, and that all completed and was verified. We then took and FlexCloned that snap to each of the developers and the QA folks to be able to do unit testing, batch processing, any of that kind of stuff for the next day's run. So a lot of the stuff that we kind of take for granted now, like a lot of people don't even know this kind of stuff exists. It's one of the reasons I wanted to get back to some Flex and SnapWord fundamentals so that we could go through each of these technologies. They're evergreen here on YouTube, and we can constantly talk about them.
And I used to argue with the product managers that Snap Manager and now its successor, Snap Center, really deserve more credit for sales than would be reflected in the attach rate. Because if you're the right kind of customer for the Snap Managers or for Snap Center, then you are going to be absolutely thrilled. But it can't do absolutely everything. But once you see it in action, you get other ideas. And even if the software doesn't orchestrate your particular application environment the way you want, it shows the power of snapshots and SnapMirror and FlexClone. And maybe Snap Center doesn't quite do what you want, but Ansible will. Or now with the REST API, I'm very thankful for this because I'm a Python guy. Used to be Perl. My goal at Oracle was I don't want to have to do anything. I want to script everything, and then I want to sit there, stare at my screen, and just browse the web, and the scripts will come and get me if something important happens. And that kind of fell by the wayside for a long time. People go, you could write a script, and the customers go, no, I can't write a script. And now that's come back again. And we've got the REST API and ONTAP, and we've got customers doing amazing things where I'll go into a meeting expecting to present Snap Center, and I'll have 10 random questions about some API calls. And then the customer says, all right, cool, we're good, bye. And they take it from there.
Wow.
So yeah, it's nice to see.
Nice. Let's get into, so you were going down the path of Active Sync as kind of introducing it with snapshots. How do we get to something as advanced as Active Sync?
So this is important to understand. So SnapMirror is about shipping snapshots around. And that was the number one reason that I was a NetApp customer for when I was at those various employers. I liked the snapshots. I liked the cost. I liked NFS a lot, but mostly it was about SnapMirror because we could move stuff around so easily between sites for DR, for migration, and nothing else could touch it. And we built on top of that. So SnapMirror Active Sync is not quite, it's different than SnapMirror. It's not merely synchronous replication. It does have some significant differences in how it works. I mean, it's still replication. So we have put it under the SnapMirror brand name. But to really understand what SnapMirror Sync does and what it's for, you do have to look deeper. It's not just SnapMirror that happens to be synchronous. It's a whole framework built up around replication. It runs on top of SnapMirror, but there's this whole other layer that you do need to know about. And I've got a bunch of slides on that.
Well, let's get started because we're already 20 minutes in from chit chat. I want to make sure we have time to get through all of this here because there's a lot here, folks, and there's a lot to go through it. So, Jeff, take us on this journey, man.
All right. So these are my SnapMirror Active Sync talking points. Now, I'm going to be using Oracle databases as an example of how this works in practice. And if you're an Oracle DBA, you're going to love this because I'll be throwing out a lot of extended rack terms and showing you a better way to do extended rack. But if you're not an Oracle DBA, the principles apply everywhere, especially to VMware clusters, but this can apply to Kubernetes clusters, to homegrown apps. The product is doing wonderful. I also should mention that this is not really new. We started with SnapMirror Synchronous, and then we had SnapMirror Business Continuity. And what we were working toward is this final state of active symmetric replication. And that's what we delivered. So don't think that this is fresh new technology. This is very well tested. It's been around for a very long time. We just added the last few orchestration pieces roughly a year ago. And I've spent, I guess, over a year beating up on SnapMirror Active Sync environments, and couldn't be happier.
Nice.
So in a nutshell, what's SnapMirror Active Sync? It's active synchronous replication. Okay. I mean, that's been around for a while. And competitively, I don't usually talk about competitors. I would rather let them talk about themselves, but it's a good example here. Competitively, SnapMirror Active Sync is a lot like Pure Active Cluster, except it's just better because we've got all the other ONTAP features, the FlexClones, the Snap Center capabilities, the API calls. But at its core, it is behaving, I guess the core replication function is very similar to what Pure Active Cluster does. Pure Active Cluster was very similar to what VMC vPlex does. vPlex was selling amazing about 5 years ago, but then I think people realized that it's a bolt-on product. You still have to find an array and manage the array.
Yeah, you still got to get a symmetrics behind it, or whatever.
Or something.
VMAX, sorry, whatever.
It works with a decent number of competitors. We've got some customers with vPlex inexplicably in front of ONTAP. I don't know why they do that, but they did. But I have not run into vPlex for a very long time outside of some weird cases where, sorry, getting overly technical, then I'll get back to this. They bought the vPlex because vPlex contains a recover point tap. And all they were doing is port mirroring of the SAN traffic for recover point purposes. That is the weirdest use case for vPlex I could think of. Sorry, I will stop geeking out about that now. Now, even if, like Snap Center, even if this isn't right for your needs, it's a really cool example of what you can do with snapshots and ONTAP and a fully integrated solution. So let's start with an example here of a typical Oracle database. I know there's a lot of numbers on here. Don't worry too much about this if you don't fully understand it, but typically, if you have an Oracle RAC database, a cluster database, you'll have maybe 3 LUNs that are for cluster control, and those are critical for the cluster. The cluster needs, all the nodes in the cluster need to access those. And then typically we have you separate the data files from the logs. So volume 1, and for you newcomers to ONTAP here, a volume is not a LUN. A volume is a management construct. You stick LUNs or files or S3 objects inside of the volume. But the volume is not a LUN. Now, other competitors use them synonymously. So we have this one management container with the cluster management LUNs. We have another volume containing 8 LUNs for the database. That's usually about the sweet spot for the data files. And then maybe 8 LUNs for the log files, the redo logs, the archive logs. And you could do a simpler example here where you've organized your VMware environment or anything else into multiple volumes containing various LUNs. So that's what you have. You've got these LUNs. And if this was a single site, you take these LUNs and you build your Oracle rack environment. Now, then you set up SnapMirror Active Sync. And you can do this at the CLI or you can do this at the GUI. And I'm a CLI person. I always will be. But I did take the GUI for a test drive. They did a great job with this. It is really, really good for figuring out what's replicating, what's healthy, what's failed over, what's not. And the setup is especially easy via the GUI because it automates multiple CLI steps.
You're referring to System Manager, the onboard management, right? Okay.
Correct. Now, here's the catch here. And that's the reason why this slide is titled right, but also wrong. This is what's happening once SnapMirror Active Sync is running. You sort of have two sets of LUNs, and they are being synchronously replicated. What actually happens when you start replication is you build your environment on one system, on, like in this case, JFS_AS Active Sync 1. So I build my LUNs there. Maybe I even built my Oracle database there. And then I enable replication. So initially what happens is you do an asynchronous SnapMirror operation. So you get a baseline copy from the source to the destination. And then it brings it into sync. And after that, there is no source or destination. It's the same LUNs. And that's why I say that this is right, but also wrong. If you really look at the systems, you've got two sets of LUNs, but logically, this is what you've built. And this is the key to really understanding SnapMirror Active Sync and how to work with it. It's the same LUNs. Don't think of this as replication anymore. I mean, it is, but it's really more like a super resilient system. It's just super HA multipathing of the same LUNs. So you've got two in this diagram. I've got two Oracle nodes, JFS 12 and JFS 13. That's what I built in my lab environment. And they have multipathing. And the multipathing will take them to the LUNs. And you don't have to worry about what's happening on the back end. You just happen to have some paths on one site, some paths on the other. And when there are failures, if you have a power failure, if you have a switch failure, if you do takeovers and givebacks, you'll have path changes. But ultimately, it's the same set of LUNs. So you don't have to really think, am I accessing these LUNs or those LUNs?
Can I jump in with a question real quick?
Okay.
When you say it's replication, but it's not replication, does that indicate, talk to me about how that happens under the covers, if you can, because there's two different ways that it's either a post-process kind of replication, just as soon as it's done with one write, it does it over there too, or is this more of like a sort of linear scale replication factor RF2 thing where it's writing the same thing to two places at the same time?
I got that in the next couple of slides here, but in a nutshell, it's protocol splitting. What happens is we make a copy from one location to another, and now it's an asynchronous SnapMirror operation initially. I mean, you don't have to worry about this. It's happening behind the scenes. And then the system will bring them into sync, and then it splits the protocol. So what you basically have is two independent systems where if one of them receives a write, it replicates it to the other side before acknowledging the write. So there is no source, there is no destination. Just every time one controller gets a write, it will replicate the change to the other side, but as well as storing it locally before proceeding. That's how everything stays in lockstep. So there isn't SnapMirror operations happening anymore after that point, unless you have a failover event that needs to be repaired. What you have is just protocols splitting the writes. That's all there is to it.
Gotcha. Okay.
Now, these are the slides I mentioned. Now, some of you will know MetroCluster. Now, what's the difference between MetroCluster and SnapMirror Active Sync? And sorry, there's a lot of words on these slides, but it takes a lot of...
I think this is important to draw the distinctions between the two. This comes up more often than not.
Yeah, I don't like having slides where people read the slides, but this is one of those exceptions where I think you need to. So the MetroCluster is sort of like one single cluster where you've got nodes across sites. SnapMirror Active Sync is basically two completely independent clusters with one minor exception that I'll get to. In a MetroCluster, you only have access from one side at a time. In the old ancient MetroCluster, there were exceptions, but right now, at any given moment, the data is available on site A or site B, but you can't read or write from both. Now, there is a copy at your remote site, and it is RPO = 0. But you can't have nodes reading and writing from that other controller. Um, MetroCluster also, I guess it scales to truly massive levels better than SnapMirror Active Sync, because with MetroCluster, the mirroring is happening way down at the RAID layer. So it's, in a way, ONTAP doesn't even know that there's replication. It's just reading and writing from the disks that happen to be mirrored across sites.
Right. Interesting. Okay.
Now, SnapMirror, like I said, is happening at the protocol level. After that initial SnapMirror, asynchronous SnapMirror update, then it switches over to this protocol splitter. I don't know if we've got an official name for it, but internally we've always called it the protocol splitter. But other than that, they're just two independent clusters mirroring writes. And that's why you can have all these mixing and matching of how you've got different clusters talking to each other. You don't have to mirror everything. In a practical matter, MetroCluster is really only used if you want to mirror the whole infrastructure. And it's awesome. I spent 6 years in Munich because we had something like 150 petabytes worth of MetroCluster hosting thousands and thousands of Oracle databases at a particular customer there. I mean, for that scale, it's fantastic. But not everybody wants that. Sometimes you just want RPO equals 0 for the VMware cluster and nothing else, or the one database and nothing else.
So a couple of questions that are timely right now. Let me throw these up on screen for us. So is it using the same traditional SnapMirror engine under the covers, or is this something unique?
It is built on top of it. So it's based, when you've initially established replication, it's a two-phase process. You get a SnapMirror update that gets each copy close to the same state. And then it basically fences the I/O. It will freeze I/O and do one last update to make it 100% identical on each side. Then the protocol splitter activates. So once the two ONTAP clusters know that each side is identical, then it knows that keeping them identical only requires mirroring the writes. And this is where the active-active component is so important. When you're reading from a controller, any controller, that controller can service the read using its local copy of the data. Now, writes have to be replicated, but the reads are always serviced locally. That's why the behavior is symmetric. So let's say that you have a VMware cluster that's spread across two sites. You don't want to do reads across your WAN. You could have half your VMs are in site A, half your VMs are in site B. All of the reads will be serviced from the local copy of the data.
Right.
And then any writes will be serviced by the write splitter. Now, let's say that you have a failover, or I'll just say site failure. If site B loses power entirely, then SnapMirror Active Sync will stop the replication. It'll give up on replication and resume operations on the surviving site. When you fix the site B and the power's back on, this is one of the nice things about SnapMirror Active Sync in my experience, it will automatically detect this failed relationship that's gone stale, and the replication will resume, and that will be another SnapMirror operation just to bring them close to the same state. And then it does the final sync, and then the protocol splitter reactivates, and then your SAN paths come back. So from a host point of view, you don't really know what's going on. You don't need to. The host just see, oh, some paths went away. Oh, now the paths are back. And that's the orchestration layer that I mentioned earlier on, and that's what makes it such a good product. You don't have to think about it. It's just paths coming and going. If the path is available, then it's a path to, in a way, the one and only LUN that just happens to have copies of itself in two different locations. But it's the same LUN. It's just paths coming and going.
Nice. Colin, I hope that answers the question there for you.
Kind of alluded to this just now, but the sweet spot for MetroCluster is that large scale replication, because you've only got the one thing to fail over. The first sweet spot for SnapMirror Active Sync is that granular replication, where you don't want to replicate absolutely everything. And also selective failover. That comes up a lot, where you've got 10 database environments, and one of them needs some hardware updates on the OS. And so you need to fail that one database environment over to the remote site, but you don't want to fail everything over. And you'd have to do that with MetroCluster. You can be granular with SnapMirror Active Sync. And then the second one was, as I mentioned, the active-active operation, where you want fully operational copies of your data on two different sites with symmetric I/O performance. No, you don't have to stretch the I/O. I'll get to this in a minute, but you don't have to stretch your SAN across sites. And you definitely do not have to read across the SAN. All access is local. If you go back 2 years and you use the predecessor to this, which was called SnapMirror Business Continuity, there were versions of that where you could read. Let's see how to explain this. I'll simplify it. You had RPO equals 0 data protection, but if you had your rack database spread across sites, one of them is getting local super low latency access to its reads, to its I/O block, its read operations. The other one is going to have to read across the WAN in some way, which means the read latencies are going to be a lot higher. And from day one, we were working toward what you see now, where we have that true active-active capability. And it works. I've cut the power hundreds of times in different configurations, just watching the pauses and the breaks and the recoveries, and it couldn't be happier. I've never had a single problem.
How do we deal with, is it something like the old, what's the E word I'm trying to think of? The old epsilon problem when you're splitting stuff like this. How do you deal with, it actually just got asked. Let me just throw it up there. How do we deal with split brain?
The mediator. Out on Tech ONTAP blogs, I've got a really long explanation of SnapMirror Active Sync with screenshots of an Oracle environment going. Maybe while I talk, somebody can go and find that and post the link in the chat.
Yeah, I'll dig it up.
It's under my name on Tech ONTAP blogs. Okay. There's a mediator, and I've got a slide on that toward the end after the SAN architecture slides. We're more than halfway through here. But that's what the mediator's for. It prevents split brains. You're not going to have a split brain. I could be wrong. I don't think if you intentionally wanted to create a split brain, you can create a split brain. Yeah. Now the SAN, with regard to SAN architecture, this is what I think is the coolest part about this, because I have worked with a lot of SAN projects. I hate stretching the SAN across sites. Either someone doesn't have the licenses, you don't have the hardware, or you just don't have the right kind of performance on that cross-site link. It just doesn't. It can be very hard. We give you the choice. So let's say you've got a simple application with SnapMirror Active Sync, and you have stretched the SAN. So if site A fails here, what's going to happen? Should have advanced quite yet. So if site A fails, you lose the power on site A. I mean, you have a copy of your data on site A, but you had no server on site B. You haven't lost data, but you're certainly going to have some disruption. And there are customers that are using SnapMirror Active Sync for this scenario. They just want the RPO equals 0, and they want reasonably convenient access to get their data back online. They'll find some servers, they'll create some VMs. I'm not sure what their plans are in most cases, but as long as they have a copy of the data, they're happy. Now, sometimes you have failover applications. VMware would be a typical example here, where you fail over from one site to another. But here's an Oracle database. So if site A fails, your database has gone down, but you haven't lost any data. If site B fails, what you're going to see here, and this is managed by the mediator, is a roughly 15-second pause. So if site B suddenly loses power, then site A is going to wait about 15 seconds before it gives up on trying to replicate data, and then it will resume operations normally. From the database point of view, what you're going to see is some paths disappear. The blue lines here will vanish because those paths are down, and the standby host would obviously, the standby host has lost power in that scenario. But these paths are still there. So these paths will pause for 15 seconds, and then your database works as usual again. If you lose this link between the sites, and again, this is described in extreme detail in that blog, same sort of thing happens. Site A will wait. I will have more on this in a little bit. Site A will wait about 15 seconds before it decides, nope, I can't replicate. And then the paths that are serviced by the site B controllers will go down, and then everything starts working again. So it's just path changes. So that's the key to this. It's the replication might be failing in the background, but the application doesn't care. The application is just seeing paths come and go. Now here's the
How does that affect ONTAP? I guess so. You explained how it affects the host, but how does that affect ONTAP under the covers? Because it's just sitting there waiting for
it really isn't
to be told to do something.
Not really. It's the protocol splitter is sort of the first stage in this. So if the protocol splitter receives a write and it can't replicate it, then it can't acknowledge it. It can't proceed. So that is coded for about a 15-second timeout right now. And there's reasons for that I'll get to. And then the protocol splitter will just decide that, okay, I can't replicate anymore, so I won't try, and I will resume operations. And but ONTAP, like what I think of as ONTAP, doesn't really know or care what's going on. I mean, it will record that there is a failed SnapMirror Active Sync relationship, but ONTAP doesn't need to do anything other than just that component that is the protocol splitter. Just stops.
Is that a function of the SVM under the covers? Is that why ONTAP doesn't care so much? Because you've just got lifts that are assigned to the SVM and it knows about all of those paths? So
yeah, it's orchestrated at the SVM layer, bringing SAN paths up and down.
Okay.
There are some components that happen at the cluster too. But, so the same questions I had before. If site A fails in this scenario, and this is like the prime use case that we were working on in engineering from day one when we were developing this, the extended Oracle rack cluster. So in this case, if Oracle site A fails, there's still an Oracle instance on site B. And you could extrapolate this to VMware. If you lose half your VMs on site A, half your VMs are still running on site B, and VMware HA can bring the VMs online on the surviving site.
Yep.
But for a database, your database is still working. One of your instances is down, but the other instance is still there. Same thing. Site B fails. Site A is still there. If the link between the sites is lost, someone has to win. And this is what the mediator will assist with. More on this in a second. But if the link between the sites is lost, one of the sites has to survive, one of them has to fail. And this is the one and only time where source and destination matter. If you look at the CLI or System Manager, you will see a reference to a SnapMirror Active Sync source and a SnapMirror Active Sync destination. I wish we'd picked different terms because that sounds like there is a directional replication happening, and that is not true. It's bidirectional, symmetric, independent replication. The only thing that matters about this source and destination is who survives if if the sites are isolated. So if you lose the replication link, the side that is currently the source will leave its paths online and resume operation. The side that is considered the destination will have its paths go offline. And you can invert that relationship if you want control over which side survives. Now here, there is an additional thing to know is we've got two modes for this SAN configuration to work: uniform networking and non-uniform. You'll see those terms in the blog and also in our documentation. This is what you get with, well, this is what you would probably want. You don't have to do this, but this is what you would get with uniform networking, meaning everything has access to all the paths. What you do is you set up a control on ONTAP so it knows which WWNs or iSCSI IDs are local and which are remote. So the end result that you get is rack node 1 will see these paths as active optimized paths, and it will use these. Now these paths work, but that's going to be crossing the WAN. You probably don't want that. You might. There are customers doing this right now where all they want is super resiliency. So you might want to allow a given server to access either path, any path in the SAN. But most people are going to be doing this with long distance. You don't want this traffic to happen if you can avoid it.
Yeah, Oracle's not really going to start crying too much until you like surpass about 20 milliseconds of latency. So as long as you've got a big link, you can kind of get away with this sometimes.
You'd be surprised. We've got most of the customers I work with now cannot tolerate more than around a millisecond of read latency, and that's pretty easy with local access, NFS, iSCSI, you name it. You can get a millisecond of latency across a WAN if you've got true dark fiber and not too much distance, but most customers that say they've got dark fiber are using that as shorthand, as private link. And that connection between your two data centers that you've leased from the telco might go through like 10 different devices and to an office clear across town before bouncing back. A millisecond of latency is not always easy.
Yeah.
So I got a little ahead of myself on those slides, but site A fails, no problem. If site A fails entirely, you've still got site B. If site B fails, you've still got site A. If the link between the sites is lost, what's going to happen is, let's say that you've lost this. Let's say site A is the source in this example. What will happen is the site A will, after the 15-second pause, will resume serving I/O over these paths, and if you've just lost the replication link, these paths to these lines will become unavailable. So this path will disappear, and rack node 1 wasn't using it in the first place, so who cares? This path is going to disappear, but this path will still be available. So rack node 2 would stay up. It's just going to be slower until you get everything fixed because it's now doing its reads across those sites.
How much does rack come into play in this situation? We haven't really talked about that. Like, isn't rack the one serving the end user or the middleware or whatever is being referenced?
Oracle Rack is an interesting product. So in a way, Oracle Rack itself is just the clusterware. It's almost like our mediator. Now, there are other things that it can do, and there's benefits to it. But what you've really got is, let's say that you've got an ordinary Oracle Rack database. Just single instance, one database. What you have here on rack node 1 is multiple threads. You might have 100 different users attached with 100 different threads, and they're all doing work on rack node 1, on this one database server. If you add rack, you've got this coordination layer, but it's kind of like half of those threads are on the other node. It doesn't work that differently. It's really, for the most part, it's an ordinary Oracle Rack database. It's just different user processes aren't all running on the same server. They're running on two different servers. And the primary
in your situation where if the link between sites is lost, I'm assuming that includes the link for rack. How does Oracle, wouldn't Oracle just fall back to using what it had access to locally?
Oracle would yell at you. Oracle will say that you need to have a dedicated link. You're not supposed to be having shared traffic. In practice, everybody does.
Fair, yes.
But let's say that the ports that you had for SnapMirror Active Sync failed. The rack database might stay online. But if you'd had a backhoe event where all access was would be cut, and this also detailed in really big detail in the blog, what would happen is ONTAP would sever this connection after 15 seconds, and then one side would work, the other side would basically go offline. The rack cluster by default will wait 30 seconds, and then one side will survive and one side will not. And you can control that as well by setting one side as the preferred survivor. Now, if you were doing this with SnapMirror Active Sync, you need to make sure that you've got the correct preferred survivors.
Yeah.
So you would want to have this be the preferred survivor and the ONTAP system on side A be the preferred survivor.
Got it. Let me see if I got any more questions coming in here. Yeah, we've got a few questions to get to. I want to get to a good stopping point, though.
Okay.
Before we do.
But let me just make the final point here. If I was using an ASA system, ASA is active-active, 100% active-active, all including SnapMirror Active Sync. If you were using this approach as a super available database server, then no, and everything's in the same data center, no problem. You'd actually get a performance improvement because that would mean that rack node 1 would be able to access the full processing power of 2 ONTAP systems, not just the one. It would be actually round robining all the IO across all the paths. Now, if you're doing this across the WAN, you might not want to do that.
Yeah.
And let me just wrap up so if you don't want to stretch the SAN, and I think this is the coolest use case, you don't have to stretch the SAN. Let's just say you've got this same rack cluster and you didn't stretch it. If site A fails, you are definitely losing the instances on site A, but site B will work. Likewise, if site B fails, site A if any interruption on site B will take out stall services on site B, but site A is still there. If the link between the sites is lost, then whichever is the preferred survivor will keep on working. But the only paths that are being used are the local paths. So this is slightly less reliable, I guess, because if you lose the link between the sites, if I had uniform networking, rack node 2 would be able to access the LUNs on site A, or vice versa. Rack node 1 could access LUNs on site B. But if I haven't stretched the SAN, that can't happen.
Right.
Do I care? I don't think so. I think it should be almost the presumed solution, just because it's so much easier than stretching the SAN across sites.
Yeah, and you almost kind of push responsibility back up the stack to Oracle a little bit. You can set the preferred host, but at that point, like, it's just going to use whatever it has locally on that in site A. If that's assuming that's the preferred host in a failover scenario, and you don't have to deal with a lot of the crisscross and deciding who's who and latencies and all that stuff.
That's another aspect of rack, where what you do with a rack database is your application connects to the rack cluster. So it reaches a rack service, and then the service can be configured in a lot of different ways, but it'll say, okay, you connect to this server, you connect to that server, you connect to this server, you connect to that server. And it basically just distributes the connections to the various rack nodes, and then it's out of it. Then you are connected to an ordinary Oracle database like any other.
It's a traffic cop.
Yeah, it's a traffic cop. And it does have an additional ability where if site B suddenly dies, it can be configured to do super rapid failover of whatever was happening at the moment of failure over to site A. It doesn't work 100% of the time, but a lot of customers do want to have that rapid failover. Now, if you're that kind of a customer, you might want to choose uniform networking, so you have fewer situations where one of your rack nodes will have to be taken offline. So maybe non-uniform isn't right for everybody. But I'd still think that, I don't know, everything is so complicated with IT these days. I think you've got bigger things to worry about than those obscure situations where certain links get cut and some don't. The simplicity of this approach, I think, would probably give you better overall reliability.
Here's another thing I'll throw in there too, because I prefer this approach as well, and here's why. Servers go down.
Yep.
Shit happens. Things are going to crash. Things are going to break. It's bound to happen. It's IT, whatever. In this instance, I'm not dealing with like a 15-second wait time for things to figure out of who's got control over. We're no epsilon process that I'm sitting waiting to hash out or any of that kind of stuff. It's just, okay, site B's offline. Just everybody use node 1 for now. And that gives me I'll do air quotes and say a downtime to diagnose what exactly is going on over in site B, without having to worry about breaking any of that unified networking, metro networking that might be going on. I prefer the simplicity of this, honestly, especially in a site where I've got this kind of redundancy.
And people underestimate the possibility of user error. Like if you have cross-site, if you stretch the SAN across the site, that's more things to go wrong. Somebody is not on the switch they thought they were on. That's something that happens. I used to get some of the strangest security questions from customers who are paranoid about liability, and they would be basically they're worried about like somebody rappelling through the air ducts in and then stealing a password from their database, but at the same time they've got hundreds of employees walking around with USB drives. I said, I will take your security concerns seriously when you lock down the USB ports.
Yes.
And now with I'm sure you've talked about ransomware protection. That's people are actually starting to pay attention to that.
Yep. Yep.
So a few notes on the mediator, and then I'm pretty much at the end here. So
Okay.
failure scenarios. We do have this mediator, and it needs to be part of the solution. You could work without it, but you're not going to like some of the limitations. So this is not really a tiebreaker. We all call it the tiebreaker. We always will probably call it the tiebreaker. It isn't doing anything. It's just an alternate communication channel where each SVM, that's when you configure SnapMirror Active Sync, it's an SVM that is sort of paired with another SVM for replication purposes. So each SVM is sending a signal directly to its partner saying, hi, are you there? Are you there? Are you there? And it gets a response. It also is saying, are you there via the mediator? So that is how we prevent split brains.
What is the mediator? Is it a Windows system? Is it a Linux server?
Linux You're typically a Linux VM. And it just securely passes messages from one side to another.
Gotcha.
So the way I describe it is it's not a tiebreaker, it's an alternate communication channel, and it enables on-tap-driven failover. You are not relying on this mediator thing to do the failover. ONTAP is in charge of the failover, and that's a good thing. That's why we can do it quick and reliably. You need the 2 heartbeat channels in order to make sure, well, basically to break the ties. So that's why it's really not a tiebreaker, but it is. So let's say that site A is considered the source and site B is the destination. If they can communicate directly with each other, everything's fine. If they could talk to each other via the mediator, they would know that each side is, well, they can verify each other's health. But if you lose, let's say that SVM2 completely lost power. If SVM1 can't contact SVM2 and SVM1 also can't contact it via this mediator channel, that's how it decides it's well and truly down.
Okay.
If you don't have the mediator, you actually can still use this, but what happens is without the mediator, if you lose connectivity between sites, you will have the source resume operations and the destination will go down. So same as always. If you lose the designated source, then you will lose everything. You have a total loss of service because the site B system will never take over for the other side unless it can verify either directly or through the mediator that it's down. If you have no mediator, it's not able to confirm that site A is really down, so it just stays offline. So I'm not sure why you'd want to be in that configuration, but the point is the mediator is not really a single point of failure. I mean, in many failure scenarios, if the mediator for some reason went down before other services, you should still be able to survive the failover event. But
from a configuration perspective, is this an all-inclusive thing where anything associated with an SVM that's configured in an active sync relationship, any volume automatically gets replicated over to its partner SVM?
No.
Or is this a volume by volume thing?
This is based on consistency groups, and that's another topic. You should take a look at TechONTAP blogs.
Yeah.
I've written about consistency groups a lot. You take a bundle of volumes, which remember are not LUNs. They contain LUNs, but you take one or more volumes and you bundle them up into a consistency group. And it's this consistency group that fails over and fails back.
Got it.
So you could have one set of SVMs with 10 different applications, and you've got 10 sets of volumes, and you can fail those back and forth independently.
Gotcha. So it's at the consistency group layer. Adding a LUN to a consistency group is the thing that sort of triggers it to be replicated to a partner SVM?
Yep. And you can snapshot consistency groups. You can snap restore consistency groups. I believe we've got FlexClone of consistent. Well, you can always FlexClone a consistency group. I'm not sure if it's a single API yet. Might be. I have not looked at that recently. But basically, you can do all of those things that you do with volumes and consistency groups. You can keep. I mean, it's still just on tap. You can do the snapshots, the clones, all of that stuff.
Nice.
And basically the final slide here. Like I said, ONTAP is this kind of misleading term, source and destination, and that implies something directional is going on, but it's really not. This is symmetric bidirectional. The only thing that controls is which side is going to resume operations and which side goes offline if you cannot replicate data. And then last thing, if you have a failure, for the most part, what you're going to see is about a 15-second pause in I/O. The host could see something longer depending on the host and the configuration you're using. This is not something that NetApp can really control. Like, let's say that the power suddenly fails on site B. If you're using some operating systems, that fiber channel frame that went missing when the power went out, that OS is going to wait 30 seconds to retry it. And there's nothing you can do to stop that. And this has scored me in my life at least 2 really cool vacations where I once flew all the way to Sweden because a customer was complaining about failover times. And I proved to them that ONTAP completed the failover and was fully ready to serve I/O in 6 seconds. And this is about 10 years ago now. I mean, we're faster now. 6 seconds, and it was capable of serving I/O. But they were using AIX. And that, depending on what happened, that's hard-coded for, I think default is 30. You can drop it to 15. You can't reduce it below 15. So there's nothing you could do. They had to change their application to handle at least a 15-second timeout because that's what the host would do. And that's why, I don't know, I guess someday maybe we will give someone the ability to have SnapMirror Active Sync have a shorter pause. I mean, we could do it. But now you are running the risk of false positives. I mean, you don't want to have a failover just because there was a little glitch on your SAN because you were updating a zone or something. And 15 seconds is about the best that you're going to really be able to count on. But like I said, we might try to do, I mean, we'll keep up. Long ago, the failover time, we're talking 15 years, the failover time for ONTAP was routinely 90 to 120 seconds.
I remember 60 seconds as the typical heartbeat for most things about 15 years ago.
But OSs didn't have all of these fast retry and abort operations for fiber channel and such, so there was no reason to go faster than 120. But as OSs got better, we tuned ONTAP to be better. So I'm sure someday we'll have something better than the 15-second, but we're kind of reliant on the OS vendors to figure out ways to do it.
Yeah.
And so to wrap up,
is that it?
I had a summary slide. Just to wrap up, this isn't really about what it does. It's about what you can do with it, where this makes extended Oracle rack so much easier, not to mention higher performance, scales better. And everything I have tested, and like I said, I've been doing this for 14 months. This is the bulk of my experimentation time. Just Oracle rack labs, try to break it. It's just doing fantastic. It's from the ONTAP point of view, it seems to be completely self-healing. There's probably a way, in most of my tests, what was even cooler is when I killed the power on like site B and the rack nodes failed on site B, they would evict themselves and then reboot. And then what I could see is that Oracle rack would wait at the boot phase for the LUNs to return. And so as soon as ONTAP had finished its reboot and brought the SnapMirror Active Sync state back to synchronous again, then the LUN paths become available, which means then the Oracle rack node detects the LUN paths are back. And then it just booted right back up again. So not only was ONTAP self-healing, the Oracle rack component of it was also self-healing.
Nice.
And I'm going to I'd love to look into more timeouts and see what I can do to tune that behavior better at the rack level, but it's great.
Well, I mean, if you have to wait for the LUNs to come back on and rack has to see those that they're back online before it can boot the node, like that takes time. That's just, it takes a long time for our systems to boot, and it takes a long time for big servers to boot.
And I suspect that there's probably an OS timeout where the OS timeout will pause. Eventually it will give up on those LUN paths coming back, and it will just resume the boot, and then you'll have a downed server. And then you would have to manually go start the Oracle rack services. But Oracle rack is loaded with little XML configuration files. I'm sure there is a way where I could say, wait for 63 years for the paths to come back.
Yeah.
That's the timeout for Linux multipathing, 63 years.
All right, let me lightning round you here to sort of wrap up the show. I want to make sure we get everybody's questions in here. Thomas obviously is a fellow NAS fan, as am I. Wanted to see why is this limited to Fiber Channel and iSCSI, and why don't NFS with VMware configurations get some love? What's the limitation?
So here's the big question: how would we do this with NFS, where you have access on both sites? If all we wanted to do is RPO equals 0, where you fail it over to the other site, meaning the LIF moves, that would be easy. But how would you do simultaneous access? Because you'd have to have 2 different IP addresses. You can't have one host stop using one IP and using another. I mean, we could, if you had non-uniform networking, you could have the same IP at 2 sites, which, if you designed your network very carefully, that might work out. But
we've seen some of this done across with stretch clustering across VXLAN type of situations, where you've got the stretch layer 2 configuration, and it's not even a replication at that point. It's more of like a indirect access sort of configuration at that point. So I hear what you're saying, and I don't know that I would ever configure it that way personally. But I can see the use case where somebody might want to do that.
Oh, yeah, absolutely. The use case is there. And SnapMirror Synchronous, which is still the foundation of all of this, that works with NAS data, but you don't have the failover component. And one of the benefits of my position, and where I spend most of my time giving people my opinions and talking to customers and solving problems, is I'm not especially plugged in with the roadmap, so I'm a little freer to speculate. I would imagine that, we must be looking at how to do this with file protocols. That I honestly can't think of what would the best way to do it. But we've had this capability with MetroCluster, and we've had customers have asked about this, and we pointed them toward MetroCluster, where you've got RPO equals 0, and if you have a failover, you have to move the LIF. And if we deliver something like this, I expect it would be the same way. It would be really nice if there was a creative way to have the multipathing. I guess you actually could do it with PNFS, but
I mean, theoretically,
it could find the optimal paths, but that's some seriously complicated programming. I mean, not unsurmountable. And honestly, PNFS just has not really caught on. It's doing better though. VMware is a little more interested in it than they used to be, but maybe NFS.
As a sidebar, where do you see in the NVMe over TCP kind of playing into this? Is it going to come into this same world in a similar way?
Without knowing, I've literally never talked to anybody about this. I know nothing about roadmaps with respect to this. I'd be surprised if they don't do it. NVMe adoption is finally picking up. It seemed to surprise people that the uptick was so small, but to me it was obvious because it took ages for OS vendors to catch up. One of the problems that we had from a NetApp point of view is there was no alternate path capability in NVMe. So if you lost a path, like takeover wouldn't work. If you have a takeover, you're down. But then finally, led by us, we got ANA, where asymmetric namespace access, I think. So now we could do it.
And deallocate finally caught.
How do you do active paths? That was a very fuzzy standard that is finally there now. That it is possible now, finally, to actually do this exact same SnapMirror Active Sync configuration using NVMe. I would assume that we're going to support that, but I don't know directly. I've always got those
I'm bringing that up.
I'm
bringing that up specifically for Thomas, because Thomas, I think you really should take a step back and look at NVMe over TCP as an alternative to NFS. I think now that we've got some of the capabilities and we've got the best of both worlds, I'll loosely say, in the power and efficient performance of block with kind of the efficiencies of Ethernet slammed together like that, and then we start stacking these technologies that have traditionally been reserved for Fiber Channel and iSCSI. Now we can use NVMe over TCP for those. Now things start coming together really nicely.
Yep. And I don't know the vVol support situation, but that also vVols have also partially or fully replaced the need for NFS for a lot of use cases. So as vVol support improves, then SAN will be an increasingly convenient option.
Yeah. Khaled asks if he has 2 nodes in rack spread across 2 locations per site in active sites. Each rack node will read from the local site. How does ONTAP? So we talked about the mediator.
The CLI commands are in that blog where what you once you configure everything, you actually go into ONTAP and you tell each cluster which worldwide numbers are local. And so when a host that is known to be local connects to that cluster, it will see active optimized paths. If it's not in that list, it will see active non-optimized paths. So that's how you can control it. Now, if you don't set that, everybody is active optimized, which might be just fine if everything is in the same data center. But if you're crossing sites, then you're going to want to configure that.
Gotcha.
Yeah, that's what you will, for all of this, for all failover operations and normal operations, you're just going to see, from the host point of view, paths will change priorities and paths might come and go, but it's always just paths to the same LUN.
Yeah. Alberto asked, I think we did cover this. Is SnapMirror synchronous using the same replication logic, of course, without the automatic failover? Are they the same thing?
Yeah, it's basically the same thing. And we say this directly in the documentation. SnapMirror Active Sync is built on top of the SnapMirror synchronous engine. It's the protocol splitter.
Perfect.
And with respect to NFS, that's another issue. So we'd have to do a protocol splitter, but LUNs are dumb. They just basically do reads and writes. And it took a while for us to get persistent reservation supported, but I believe that's there now. With NFS, this gets not insurmountable, but a lot more complicated, where if you really wanted to do fully active access across sites with multiple IP addresses and on different sites, you've got to replicate lock states, lease states, delegation states. There's a lot of stuff that would have to be kept in sync across sites. So, I mean, not insurmountable, but a whole lot more complicated than SAN.
Yeah, very true, very true. Colin had another question. Is this supported between 2 CVOs or between 2 different ONTAP flavors? Any minimum latency requirements between the 2 sides? Have we done this with CVO?
I don't know why it wouldn't work with CVO, but I honestly don't know.
ONTAP is ONTAP, so
yeah.
Yeah.
The latency requirements are, it's in the documentation. I want to say it was something like 10 milliseconds. Maybe it was 20, but I think it was 10. Honestly, if you had 10 milliseconds of latency, that's probably not usable anyway, just because
I wouldn't want to depend on that. Yeah.
Yeah. I mean, an Oracle database is not going to be happy with 10 milliseconds of write latency. Remember, the read latency can still be microseconds because you can always read from the local copy, but the write latency will be limited by the cross-site replication. You can't stop that.
Let's see what we got here. Can we swap source and destination for the SVMs while in prod?
Yep.
And also remove the secondary for a real online site migration. So could we leverage something like SMAS to do some kind of site migration?
Yeah, absolutely. I had the same rack environment for most of my tests, and as I updated ONTAP versions, and a couple of times I was using engineering releases where I broke something, I tore down and recreated the replication relationship multiple times. So absolutely, you could use this for migration. You can flip-flop who's primary and who's secondary. I've got an example of that in the blog post. You see an IO pause of like a second when the moment that authority for the relationship transfers from one side to another, but other than that, nothing.
Yeah.
You can do that.
It's like dropping a ping when you're putting a laggard together or something like that. You're always going to drop some kind of ping. You're going to have one missed, one little bit of latency there in any kind of cutover. Let's see. Thank you very much for that question there. Support for Snap Center. That's something I thought about throughout the show today as well. Like, how does this interplay with Snap Center? Is this like, where do you see this Snap Center kind of fitting into the bigger picture of this?
Let's see. Well, Snap Center does not really have a DR capability, so this would certainly be complementary to Snap Center. I think that Snap Center can manage a database that's replicated via, well, manage any application replicated via SnapMirror Active Sync, but you would want to double check on that. I can't think of any APIs that it would get confused with. The one thing I don't know about that I would definitely want to check on is if you're using Snap Center, you often have SnapMirror asynchronous as well. And having SnapMirror async of data that's also replicated with SnapMirror Active Sync, you're going to have some considerations there. I don't know exactly what all of those are. I'm pretty sure that they're spelled out in the documentation on docs.netapp.com, but I've not looked at that recently.
I would be cautious of ultra databasing an Oracle system that was in an active sync kind of relationship as well, to be able to quiesce and snap it. I'm not sure
that part of it should be fine.
Okay.
I know you did a ton of stuff with 10G. They changed the architecture of how this all works. In that time frame. It really should be just like throwing a switch now. The only thing that I just don't know, I mean, there's no reason why Snap Center shouldn't work. I'm just wondering, is there some sort of like an API call that it's making where if it detects a volume that is being replicated with SnapMirror Active Sync, is it going to be basically confused? And there's, again, minor things that could certainly be addressed easily. It's just, does the latest patch release for Snap Center cover that? And that's what I don't know. But I mean, it should be just taking snapshots and clones as usual. I mean, long term, I personally would love to see Snap Center have more of a DR capability in it. Well, no, even then, I guess that doesn't really matter here because Snap Center Active Sync is DR. You don't need anything else to happen.
I look at Snap Center as a meta snap manager, a manager of snap managers. So I look at it in the context of how did I use that back in the day? And we would quiesce, snapshot, and then as a post process, if necessary, trigger a SnapMirror resync or SnapMirror update, whatever it was back then. So that it was never really intended to be a DR tool. It was a backup tool.
Yep.
So I think there's a difference between backup, DR, and continuous availability. I think those are three separate sort of pillars of business continuity.
Yep, I probably said hundreds of times to customers, Snap Manager by itself is not a DR tool, but the snapshots it creates can be used as part of a DR process.
That's a great way to say it. Yeah. Thanks for all the great questions, Khaled. Let's see any more in here. Can it do Fabric Pool? Like, does that jump out?
Send protocol. Oh, does it work with Fabric Pool? I don't believe so. I don't see how it could, but I have not looked into that. On the whole, you don't run the types of workloads that are going to be used with SnapMirror Active Sync are highly unlikely to be using Fabric Pool.
Fair.
There's exceptions, but that's not the prime use case for this.
Yeah, you're not going to see a lot of cold data sitting around in these kinds of configurations.
Yep. We have actually done a fair amount of testing with Oracle and Fabric Pool. It's not, if you have an actual storage grid appliance, the latency hit from having tiered data is workable. I mean, it's one of those things where I know there are customers out there that would benefit hugely from having their giant databases backed with Fabric Pool. I don't know how to figure out who they are because like there's a lot of people that would like to do that. Only some of them would be able to handle the latency overhead. And I don't know.
Is this a Goldblum thing? Just because you can doesn't mean you should.
Yeah.
Like, is that I feel like it falls into that category.
Yeah. If you've got a customer that's a big time tinkerer, go for it. But
Troy's a pretty big tinkerer.
As an example, there's archival products that sort of work like Fabric Pool, where what they would do is take cold data out of a database and then zip them up into giant flat files. And then if you suddenly realize, I need to see Nick's phone bill from 2016. What it would do is they would hand off to the archival app that would unzip this giant file, find that phone bill data, and then return it to you. And that takes time. That could take minutes. But if it happens rare enough, do you necessarily care? So there were a lot of products like that. And Fabric Pool would certainly have a much lower performance hit than that. So we know that there are use cases out there where this would work. But again, how do you detect who those are without a lot of consultation?
Yeah.
And please don't just throw it in there as a way to save money. I've seen that happen before. It does not work well with databases. That's a risk.
Finally, the last one here, Colin wants to know any chance of getting an Oracle rack with Active Sync as a lab on demand.
I've talked to the lab on demand guys about it. I don't know what they've done.
Okay,
but
we'll go harass Toby in Discord.
Well, here's the nice thing about it, and this is also mentioned in my blog. There's not much to it. It's what you do is you set up the baseline LUNs and then install Oracle Rack. You don't do anything special. The fact that you're using SnapMirror Active Sync is basically irrelevant to Oracle Rack. Actually, it simplifies it because you don't have to worry about what's called ASM fail groups. You just treat it as a single site Oracle Rack database, and it's not really extended at all.
Well, I just shivered a little bit, Jeff. Oh, ASM is not something I've heard a lot in a while. Yeah, I think that's it. Thank you so much for an amazing presentation. I hope you come join us in our Discord community. We got a lot of fans in there, a lot of people that love geeking out about this kind of stuff. Any follow-up questions that they may have, I'll shoot them over to you, and we'll see if we can get those answered. But thank you so much for a great talk today. This was really insightful. Really, I mean, even for me, I had not done a lot with Active Sync at this point. Yeah,
so you're welcome. And I encourage everybody, give it a whirl. I guarantee you got use cases for this. And I'm known as being a little grumpy about features because everything NetApp does, I want it to be built for databases. I don't care about that VMware, SAP stuff. Build it for Oracle databases. And so I complain a lot, and I got no complaints about this. It's just great. They did everything exactly as I'd hoped.
What beyond Oracle databases, just as a quick closer here, where else do you see this pretty prevalent?
VMware is probably VMware. I'd say VMware clusters across sites, I'd say, are more important of a use case. It's just simpler because it just kind of works. VMware HA can figure out which paths are available and which data stores are available. And I'm sure there's tuning things that Chance will eventually discuss, but it's not that hard to do. Oracle Rack is touchier, so we needed to know exactly what's going to happen. The timeouts matter a lot. Delays matter a lot. Latency matters a lot. And so I gave a ton of feedback to the PM team when we were designing this, and they delivered.
Awesome. Well, Jeff, thank you so much. Enjoy the rest of your day. Happy holidays, all that good stuff. And maybe we'll get you back on here for an update soon.
All right, sounds good. See ya.
All right. Thank you, sir. Well, there we go, guys. SnapMirror Active Sync. A lot of that was fairly new to me. I honestly didn't know that ONTAP could do all that stuff. And some of it I kind of took for granted because some of it we've been doing for a really long time. Some of it I did a long time ago with Oracle and some of our local WAN, stretch WAN type stuff that we would do. But anyway, there's so much more to go over. So many more Flex and Snap words. We're going to start getting back to the basics. And if you're subscribed here to the channel, you're going to start seeing some videos come on in the new year that are going to go break down some of these things that Jeff and I were talking about at the beginning. Some of the more 101 fundamentals, like what are snapshots? The old ABC diagrams, if you guys remember those. What are flex clones? And all of the things in between. So we're going to get into all of that stuff in 2025. We're going to keep this show going every week. So make sure you subscribe to the YouTube channel. Make sure you've got your notifications turned on so that you know that anytime there's a new video or a new episode of On Air posted, you can get access to it. We got to say, producer Drew from behind the scenes decided to make a showing. He's on the other side of the world today, or this week. Yeah, it must be a good show. Of course it's a good show. I mean, they're all good, aren't they? Guys, enjoy the rest of your week. We'll be back next week with Elliot Ekton going over FlexCache. Again, that's another one of those sort of niche use cases that I've not really heard or done that much with, I should say. But it is incredibly powerful. And especially for those of you that are running, either multi-site or global footprints of stretching data around the world, you're not going to want to miss that one, because that is I think one of the most powerful hidden gems of ONTAP is FlexCache. And that's what we're going to close the year out with. So if we don't see you next week, happy holidays, happy new year. We'll see you guys in January, but we got one more for you next week. So don't go anywhere. Until next time, guys, thank you so much. Really appreciate it. Take care.